two or more numbers are multiplied together, the result is a product, and those numbers are called factors. For example, 2 times 3 is equal to 6. 2 and 3 are factors of 6. The factors of 35x squared minus 14x are 7x and 5x minus 2. So x squared plus x over x, when we do the division, we get x plus 1. Now, to factor, because factoring is a special type of division, we will multiply the divisor, which is x, by the quotient, which is x plus 1. So x squared plus x in factored form is x times x plus 1. So let's see the relationship between the division and factoring. First, we're going to divide 15x cubed plus 25x squared divided by 5x squared. Our first move is to separate the terms and then divide the monomial. We get 3x plus 5. So the quotient is 3x plus 5. The divisor is 5x squared. So now when we need to factor, we'll just multiply the quotient 3x plus 5 by the divisor 5x squared. So 15x cubed plus 25x squared in factored form is 5x squared times 3x plus 5. 5x squared times 3x plus 5. When looking for the greatest common factor, we get the greatest common factor of the numerical coefficient and then the greatest common factor of the variable. For example, 36 is 2 times 3 times 3, and 12 is 4 times 3, which is 2 times 2 times 3. So the greatest common factor between 12 and 36 is just 12, which is 2 times 2 times 3. And for the variable, it's a lot simpler. For the variable, the greatest common factor is the common variable with the smaller exponent. So between x to the fourth and x cubed, the greatest common factor is x cubed. X to the fourth is x cubed times x1, and x cubed is just x cubed. Therefore, the greatest common factor is 12x cubed. The GCF between 20 and 30. 20 is 2 times 10 and 30 is 3 times 10. So the GCF is 10. Between x cubed and x squared is x squared. Between y to the fourth and y to the third, it's y to the third, the variable with the lesser exponent. Now, 12, for example, 12 is 2 times 2 times 3, and 18 is 2 times 9, which is 3 times 3. So the GCF between 12 and 18 is 6. Now that we have the GCF of the numerical coefficients, the GCF, we're going to look for the GCF for the variable between a fifth and a to the second is a to the second. between b to the third and b to the fourth, it's b to the third. Now c is just by itself. We're going to multiply a plus b by a minus b. When a plus b is multiplied by a minus b, let's see what happened. We're going to distribute a over a minus b. Therefore, we have a times a minus b, and we're going to distribute b over a minus b plus b times a minus b. The result is a squared minus ab plus ba, which is the same as ab, minus b squared. Minus ab plus ab canceled. We obtain a squared minus b squared, a difference of two perfect squares. Similarly, x minus 2 times x plus 2 will give us, according to the formula, x squared minus b squared, which is 2 times 2, which is 4. So if we know that we have a difference of two squares, then we just have to apply this formula. A squared minus b squared is equal to a plus b times a minus b. A squared minus b squared is equal to a plus b times a minus b. The following examples are difference of two perfect squares. X squared minus 9 is equal to x plus 3 times x minus 3. 9x squared minus 25. Remember, 9x squared is 3x times 3x. So it's 3x squared. So 9x squared minus 25 will be 3x plus 5 times 3x minus 5. Similarly, 16x squared minus 49y squared. 16x squared is 4x between parentheses squared, and 49y squared is 7y parentheses squared. Therefore, we have a difference of two squares, and the answer will be 4x minus 7y times 4x plus 7y. Let's do 9x squared y squared minus 4z squared. Let's write them as a difference of two perfect squares. 3xy between parentheses squared minus 2z between parentheses squared. So the answer will be 3xy plus 2z times 3xy minus 2z. And the last one is x to the fourth minus 25. X to the fourth is x squared squared minus 5 squared. The answer, x squared plus 5 times x squared minus 5.